Hello, hello, and welcome to a little video about Target 1A, recognizing function and function families. All right, so a relation is the relationship between sets of inputs and outputs. The various kinds of relationships we can have are ordered pairs, equations, verbal ones, so just written in English. We can have maps, graphs, and tables. Now, functions in particular are relations that have each element of the domain, so the x's, the inputs, go with exactly one of the range values, which is our outputs or our y's. And functions can be represented in various ways. So first, let's take a look at the table and see whether or not the table represents a function. So the domain. Does the domain ever repeat, or does each domain go to exactly one range? For me, it looks like every domain goes to one range. Now I know that 5 and the 6 both get an answer of -5, but the domain of 5 only happens once, and the domain of 6 only happens once. So the table is a function because the domain goes exactly to one range. Yes, each domain only goes to one range. All right, next let's take a look at the map. All right, so this is a map. Does each domain go to exactly one range? Hopefully you can see that the domain of 4 goes to 2 different ranges. So this, unfortunately, is not a function. It's a relation, just not a function. No, the domain 4 goes to 2 ranges. Ay, ay, ay. Next, let's take a look at the ordered pairs. Here are my ordered pairs. Now for ordered pairs, I'm just looking at my x's because they represent the domain, the inputs. So I have -2, 0, 3, and 3. Boo! Did you see how I said 3 twice? That means this is not a function. That domain repeated. No. The x3 repeated. So, we cannot have the x's repeat. Well, let's write that down. Functions can't have repeating. And this is going to be synonyms. We can't have repeating x's. Domain or input. Now, when we have a graph, we can't just look at the set of x's and y's without having to write them down or using technology. So what we do instead is use a vertical line test, and to see how many times the vertical line crosses the graph. Now, if our vertical line crosses 2 or more times, it is not a function. Kind of like having an x repeat. You can't have that. That's a no-no. So let's take a look at number 4 and determine whether these graphs are functions. So for 4a, I'm going to draw a line down the graph. See how it only crosses one time? That means it is a function. For b, let's draw the line through it. Now for b, you're going to pretend that's a straight line. It crosses twice, not a function. For letter C, let's draw a line through a point. Oh, ew, did I choose black? I wanted to use purple. Purple! Oh, I missed. Let's try one more time. Purple! There we go. My vertical line that we're pretending is straight only crossed one time. So yes, this is a function. Now, when we have a function and we'd like to represent it as an equation, we must use function notation to specifically state that it's a function, not just a relation. Instead of using y equals, we're going to be using an f with x in parentheses. Now, the way we read f of with x in parentheses is f of x. So f of x is the same thing as y. The way we can tell if an equation is a function or not is by plugging in a number and seeing if we get one answer or two. For number 5, let's test if this is a function. We're going to plug 3 into every x that we see. So instead of f of x, we have f of 3 equals 4 times 3 minus 6. 4 times 3 is 12. 12 minus 6 is 6. So f of 3 equals 6. We only got one answer. This is a function. Let's try it again for this problem. Here I have g of x, but you know what? It doesn't matter. As long as there's a letter in front of the parentheses with x, it's a function. We can have a of x, b of x, c of x, anything of x. In this case, instead of x, we're plugging in 4. So I have g of 4 equals 2 to the power of 4 plus 3. 2 to the power of 4 is 16, plus 3 is 19. So g of 4 is 19. Of course, you could use a calculator to figure that out. You don't need to do it in your head. Next, we got to talk about domain and range, because that's something we really look at when we're talking about functions and relations. Domain is the set of all independent values, and those are going to be the x's. Let's spell independent. There we go. Range, on the other hand, is the set of dependent values, and those are the y's. The answer we get in our for our equation or for our function depends on what we plug into it. X gets plugged in. It doesn't matter what x is, we plug it in. It's independent. The answer depends on that. That's why y is dependent. When we state domain and range, we always go smallest to largest. So let's do that for numbers 7, 8, and 9. Our domain is a list of x's. When we write a list of x's, what we really need to do, or in math, we use squiggly brackets. Squiggly brackets represent the word, the set of, or the words. We love abbreviating in math. So instead of 3 words, we're writing a squiggle. Perfect. For the x's, it's 0, 2, 4, 6, and 8. Squiggle. And we just learned that f of x is the same thing as y, so for our range, 4, 5, 6, 7, and 8. Don't forget to include commas. For number 8, let's do domain and range. We have 0, 1. 1 repeats, but I only need to write it once. 2 and 4. For our range, 1, 2, 3, 4, and 5. Now, because this 1 repeats, this is not a function. Next, let's look at number 9. Our domain is still our set of x's. So, I'm going to list my x's in numerical order, smallest to largest. -3, -2, -1, 0, 1, and 2. For my range, I'm going to do the set of y's. Color coding really helps me see them better and not mix things up. Okay. Oh, what did I just do? Nothing. Okay. So, range. The smallest is -2, then 0, then 1, 4, and 9. Beautiful. Now, we're going to also do domain and range based on a graph. And we're still going smallest to largest. Now, on our graph, the x's go from right to left, and our y's go from left. I'm going to say that again. X's go from left to right, and y's go from bottom to the top. So let's see how far right and left my x's go. On the very left, my x's, let's see, they go to -1. And on the right, 4. So, for my domain, my smallest number is -1. which is less than or equal to x, which is less than or equal to 4. Let's do the same thing for y's. Now our y's go from bottom to the top, that's smallest to largest. So the bottom of my graph exists right here at -2, and the top exists at 3. So my y's go from -2 to 3. Okay. Now our graph is made up of 3 sections. There's one that goes down, one that's flat, and then down again. Now instead of saying down and flat, we're going to call things decreasing and constant. If our graph went up, I'd call it increasing. When we're talking about these intervals of decreasing or increasing, what we need to do is write our notation similarly to how we wrote it up here with the inequality symbols. So let's check it out for letter B. I do not have anything increasing. I do have decreasing and constant. I just don't have any part of my graph that goes up. So, decreasing. D for decreasing. Let's see. I start at, oh, by the way, when we're looking at increasing and decreasing and constant intervals, we're only looking at the independent values, only at the x's. So, it looks like I'm decreasing. Let's highlight. From -1 all the way to +1. Let's write that down. Decreasing. From -1 to +1. That's my explanation. All right, what happens next? Next I have a flat part. Flat, 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 flat. From 1 to 3. Our flat parts are called constant. It goes from 1 to 3. The next portion of my graph is going down, so it's decreasing from 3 to 4. From 3 to 4. So we have 2 decreasing sections, 1 constant section, and that's it. All right, number 11. Let's do the same thing. I'm going to zoom in just a little bit more. Okay, domain and range. Domain goes left to right. Our domain starts here, so that's -7. And it ends right here at 6. Our range goes from bottom to top. The bottom of my graph is at -2. Doesn't go any lower than that. And it reaches the top at 8. Okay, fantastic. Okay, so letter B. Is the graph increasing, decreasing, both, or constant? Now we're going to prove it by showing it. I like to just start off left to right on my graph and see where we're going from there. Okay, it looks like the first little section of my graph is constant. C for constant. From -7, sorry about that noise, all the way to -4. Okay. The next section looks like it's going upwards. Upwards is increasing. Whoa, my bad. Let's do that one more time. There we go. Increasing, I for increasing. And I'm increasing from -4 all the way, where does it go till? To 1. Okay. Then it looks like I'm going downhill, I'm decreasing. So I have all of the parts. I'm decreasing from, where am I starting from? Oh, I'm starting from 1. And I'm decreasing all the way to where I end at 6. Beautiful. Okay, that's it for Target 1A. If you have any questions, please feel free to ask me or whoever it is you're working with on this. And have a wonderful rest of your day. Bye.